Greetings, it's Stacy from Hexinverter. I'm super excited to be showing you Mindphaser today. It is finally going into production. Some of you who have been following the development of Mindphaser from the beginning know that it's taken a while to get here. What you see now is its final form, after multiple iterations, prototypes, and fine-tuning. There have been some refinements of the feature set since the initial overview we did for Superbooth 2018. So if you saw that video, I definitely encourage you to watch this demo to check out all that the module has to offer. This video is going to be a technical presentation. To clarify, I won't be banging out some sick Jordan Rudess riffs on the keyboard, or really doing anything very creative with it for that matter. My hope is that this video works as a kind of living user manual and gives you an idea of how the module works and how it might fit into your modular system. I encourage you to check out this sister video made by Dash Glitch for something more musical. I'll link it here and in the video description for you to go see. So without further delay, let's get into it. We'll begin with a high-level overview of the architecture of Mindphaser. Mindphaser is a dual complex oscillator. It generates interesting sounds by using two VCO cores, the carrier and modulator, a palette of intermodulation capability through the Mod Bus and the through-zero phase modulation bus, as well as the tools offered by the Waveshaper. The VCO cores in Mindphaser are each a precision ramp wave oscillator. They range from subsonic frequencies all the way up to supersonic frequencies with very stable waveform outputs for each. You may be asking, especially if you've seen the earlier specifications for Mindphaser, why ramp wave? Well, actually, for this type of phase modulation that we're doing here, a ramp wave results in a better, more stable sine wave output when doing phase modulation. Hence, for Mindphaser, it didn't make sense to use a triangle core oscillator like some other VCOs you may be familiar with. Each VCO core has a coarse and fine-tuning knob for manual control, which is probably familiar to you if you've worked with analog oscillators before. The simultaneous waveform outputs are probably familiar to you as well. What may be a little bit different is that in Mindphaser, we have the ability to switch the phase, in other words, invert the signal for the ramp or sawtooth wave output at any given time. For example, here is our trusty ramp wave coming out of the carrier, and as we cycle through the modes, we'll see that it inverts its phase. We also have the ability to switch the octave of the modulator. This is very useful because the oscillators are such high range that this way you can switch very easily between LFO frequencies and higher audio rate frequencies. The panel reflects this at all times to let you know where you are. The majority of interesting sounds you'll create will probably come from the main output at the bottom right of the module. The signal flow goes from the carrier, which provides the heartbeat. It feeds the Waveshaper, and then the through-zero phase modulation bus, arriving at the main output at the end. Besides the intermodulation capability and arrangement of multiple oscillators to work together, one of the things that makes most complex oscillators interesting is their waveshaping toolkit. Mindphaser is no different in this regard. Mindphaser's wavefolder circuitry is unique in that it's an analog, discrete, trigonometric function generator. What this means is that at base folds, you have a sine wave output. The carrier feeds the Waveshaper. Within the Waveshaper, you can wavefold up to 5 octaves above the fundamental. Notice that the waveform itself begins to flatline and clip at extremes. This is intentional, as it can produce some very interesting effects. We also have feedback effects within the wave folder itself. We also have full range or through zero amplitude modulation. In its most basic form, you can use this like a VCA if you want by plugging in an external CV input. It controls the level of the main output. Of course, it allows you to also do through zero amplitude modulation, which can be very interesting indeed. A final wave shaping stage in order to introduce even more harmonics is a soft clipping at the final output. In combination with feedback, things can get pretty wild pretty fast. In case it wasn't obvious, the entire wave shaper is built around introducing as much harmonic content as possible. The wave shaping circuitry in Mindphaser has two distinct shape modes that it can operate in, controlled by this switch here, which are indicated by the color of the LEDs on this section of the panel. We have triangular mode and rhampoid mode. The difference is most apparent when you begin folding. So to demonstrate, this is what triangular folding looks like. It's the mode we've been in so far. And this is the same thing with rhampoid. As you can see, the way in which the waveform actually folds between sine waves is different. The different modes have dramatic effect on the overall output of Mindphaser, so I encourage you to experiment. The through zero phase modulation bus on Mindphaser is pretty unique. It's independent of the actual VCO cores themselves. This means that when you apply, say, linear FM to the carrier, it's actually completely independent of the phase modulation occurring. The phase modulation bus features a manual index control, a manual phase control, and the modulator oscillator's sine wave output is by default normaled to provide the phase modulation source. It's a good idea when you're first starting with a sound to start with a bass sine wave like we have here. The manual phase control is useful to zero out that sine wave. We can demonstrate manual phase modulation here by looking at the way that the waveform changes when we wiggle the phase control. The wavefolder shape that we talked about earlier, that is switching between the triangular and rhampoid modes, have a huge effect on how the phase modulation works as well. This is because actually the phase modulation bus is a component of the wave shaper. That's why it's over here on this section of the panel. So this is what it looks like in triangular mode, and for true through zero phase modulation, we can see here in rhampoid mode the only thing that changes is the actual phase of the sine wave in relation to our fundamental heartbeat coming from the carrier. Now we'll take a look at bringing in some phase modulation from the modulator, turning up the index. And now in rhampoid mode. You'll notice again that we've allowed the controls on the phase modulation index to go to extremes. You'll probably notice the small ramp wave glitch on the sine wave when in rhampoid mode. This is completely normal and is just a side effect of doing this type of phase modulation in analog. As you can see, it never goes away. This of course can be filtered out if you want to use something like a low-pass filter after the module. But we wanted to keep the sound coming out of Mindphaser as pure and unadulterated as possible, as would be with a complex oscillator, where you're adding harmonics as opposed to subtracting them in subtractive synthesis. The octave range switch on the modulator is very useful for experimenting with different phase modulation sidebands. As you can see, the ranges you can flip through with this switch are huge. The indicator shows you when you've gone into LFO mode and jumped a steep drop down into LFO ranges. In addition to the internal modulation oscillator being routed, we also have an external source input for the through zero phase modulation bus, where you can plug any signal in, be it audio rate or modulation rate. Moving over to the modulation bus, this is where things get really interesting with Mindphaser. The modulator core feeds this bus by default. However, again, you can plug any external source into the source input. The mod bus is completely separate from the phase modulation bus. This, of course, makes things a lot more parametric, as you can control the index of phase modulation and the modulation oscillator separately. The glyph above the mod bus lights up to indicate whatever the CV is coming out of the mod bus at the time. As you can see right now, it's following the triangle wave of the modulation oscillator. You can plug any source into the mod bus. However, by default, there's a switch to select which of the waveforms from the modulation oscillator you want to send to the rest of the module. The internal modulation bus in Mindphaser can send its modulation signals almost everywhere on Mindphaser. Anywhere you see a triangle glyph by a CV control indicates that the mod bus will send there. In order to send an internal modulation signal through the mod bus to one of these destinations, we simply turn up the attenuator and make sure that the main mod bus index is turned up. As you can see, now we're modulating the wavefold position. Something unique to Mindphaser, and this is a performance feature which we came up with, is that each of these small trimmer knobs go from 0 to 100% attenuation. This is just like a regular CV attenuator. However, these inputs are in fact bipolar, so you can invert the signal by simply toggling the CV inversion for that input. Each of these buttons controls their respective CV input. So, bringing in some various modulation going on here. Let's get the frequency up. And here we have some through zero amplitude modulation, some wavefolding, maybe bring in some phase modulation. Just a touch. In this way, the index control, once you have some Modbus destination amounts dialed in, the index control works as sort of a main modulation control, bringing all of those destinations with their various amounts and polarities in or out at once. Both oscillator cores on Mindphaser have hard sync enabled in their cores. The carrier oscillator has a dedicated external sync input, and the modulator has a switch to basically make it follow the carrier, so the heartbeat from the carrier will feed over to the modulator when you turn on the sync switch. This is most evident, obviously, when looking at the modulator waveform, but I encourage you to play with phase modulation while doing this, because it can be very interesting indeed. You get phase modulation without any oscillator drift in between, and of course, like regular hard sync, changing through frequencies creates some interesting effects. Now that we've had a little high-level overview of the module, I'm going to go through some different examples with Mindphaser using the oscilloscope screen here just to show you some differences between features and potential use cases for different modes in the module. Again, these aren't going to be very musical at all. It's just to show you what things look like and so that you understand what's going on in the module. The feedback control in the Waveshaper, when the folds are turned to 0, it actually behaves in order to change the sine into a more basic wave shape. To illustrate, let's see it in triangular mode. When we turn up the feedback and the folds are set to 0, we eventually get what looks like a triangle wave. In rampoid mode, we eventually get what looks like a ramp wave. This can be useful if for some reason you're trying to morph between basic wave shapes and something complex. Of course, it's going to be fed back when you bring up the folds, but this is an interesting observation. As mentioned previously, the linear FM input and the through zero phase modulation bus are completely separate. So that means our mod bus, because it provides the source for linear FM, if we bring in some mod bus doing FM, as you can hear here, and we look at the phase modulation. Now, if you bear with me and we switch over to the just raw VCO core output of the carrier, we can see that this is frequency modulated, but phase modulation does nothing to the actual VCO core. These two features, when combined or used back and forth interchangeably, perhaps with modulation, can be pretty interesting. The pulse width modulation and the saw inversion for the modulation oscillator, of course, determine how that waveform looks when it's coming out of the Modbus. This is a useful observation to keep in mind because if you invert the rampoid output of the modulator into a saw, it makes a pretty big difference when you're in LFO ranges, as demonstrated here. Now inverting it. And back again. And this is, of course, because the waveform is either starting up high and going down, or starting down low and going up. One interesting effect that can be achieved from the fact that the wave folder is designed so that it can overload like this is that when in extreme positions, adjusting the phase control is almost like pulse width modulation would be on a square wave, except it's on a complex waveform. This, of course, gets very interesting when you start modulating it with CV, which in this case, all we have to do is use the phase modulation input. So as you can see, I'm bringing in an LFO from the modulation oscillator. So of course, things don't end within the module with Mindphaser. As you can see, I've barely patched anything, so it's very fun to bring in external sources as well and combine them with the Modbus. Here's an example of bringing in some amplitude modulation externally. And then introducing phase modulation delivered by the internal modulation oscillator. terms of availability, this module is finally in production. You can now pre-order the module for delivery in Q1 of 2021. So I hope you've enjoyed this short introduction to Mindphaser and the overview. Let me know in the comments if you have any questions. I try to get to them when time allows.